All right, let's get ready to answer this question. All right, so it says given sine of theta is equal to 3 over 5, the angle theta lies in quadrant 2. And the part that's missing from this question that they want us to find is they want us to find all six trig functions given this information. Now, all six, what do we mean by that? If you scroll down, they want us to find sine, cosine, tangent, as well as the reciprocal functions, cosecant, secant, and cotangent. All right, so let's get into that. First step that they tell us to do is use the information given to determine what trig functions will be positive. Well, I throw back to my ASTC, and that automatically tells me that guess what? If I'm in quadrant 2, I know that sine is positive. So then that means that sine is going to be positive, but it also means the reciprocal function, the flipped function, cosecant, is also going to be positive. Once I have this information, I'm going to go right down to the bottom, and I'm going to put in some signs. Sine is going to be positive, as we just said. Cosecant is going to be positive, and everything else is going to be negative. We in quadrant 2. Doing this early kind of saves you a lot of work when we get later, and you'll see how. Our next step, it says draw a triangle based off of the quadrant and what trig function is positive, okay? So I'm going to show you how to draw all the triangles, and then I'm going to show you the triangle that we need, okay? So when you are in quadrant 1, you just draw the triangle from the center out, and theta is right back towards the center. When you're in quadrant 2, you draw it from the center out, and theta is right here. If you're in quadrant 3, you draw it again from the center out, and theta is here. And if you're in quadrant 4, you draw it from the center out, and theta is right here. These are all the triangles. But in this problem, we're in what quadrant? 2. That's right, quadrant 2. So we only really need one triangle, and that would be the one right here in quadrant 2. With theta there. Now, with theta being here, that will automatically let me know that this is my opposite. I'm going to just throw my little O here. And this would be my hypotenuse up top. And then on the bottom would be my adjacent. Okay? Now, they also gave us an important piece of information that says sine of theta is 3 over 5. Sine of theta we know is so. So that means that my opposite is going to be 3, and my hypotenuse is going to be 5. That leaves us with no adjacent. But we learned a method to solve for the adjacent here. What technique would we use to solve for the adjacent? What would that be called again? You got it. The Pythagorean theorem. So if we're moving forward, are we solving for a leg or a hypotenuse? Yeah, it's a leg. So then that means that if we're solving for a leg, when we plug into it now, using the information that we have, we're going to be x squared, representing the leg that I need to know, plus the other leg, which is 3 squared, equals to my hypotenuse, which is 5 squared. Cool. Now, once I have this set, I'm just going to solve for it. So x squared, I know I'm going to bring down this x squared. 3 squared, I know is going to be 9. And 5 squared, I know is 25. From here, I'm going to subtract 9 on both sides. Subtract 9. This cancels, and I'm left with x squared equals to 25 minus 9, which is 16. Boom. So then now that I have that, I can go ahead and finish solving, right? If I take the square root of both sides, the square root of x squared is going to give me x. And the square root of 16 is going to give me plus or minus 4. Plus or minus, because a positive or a negative number to the second power can give us 16. But because we're working with a length, we're going to use the positive 4. Now, the value of this is that I'm going to take my same triangle that I drew earlier. See this one over here? I'm going to bring it down, but now I know my x is equal to 4. So right here, have my theta there. I got my 3 here. I have my 5 here. I got my 4. Let me put my labels on again. I know this is opposite the angle. Across from the right angle is my hypotenuse, also the longest side. And then over here is going to be my adjacent. Boom. Once you here, you've done majority of the hard work. From here, I want sine. We know that's so. That's just opposite over hypotenuse. So we got positive 3 over 5. Cosine theta is the reciprocal function. It's just the flip. So that's going to be positive 5 over 3. Then you're going to have cosine theta over here. Excuse me. That was cosecant theta. Hope I didn't say cosine. Cosecant theta is 5 over 3. Cosine theta, we know that's co. So that's going to be adjacent over hypotenuse. 4 over 5. I know it's going to be negative based off the quadrant, and that's why I put the negative there earlier. Then secant theta is just the reciprocal, the flip, minus 5 over 4. Last but not least, TOA, tangent. We know that's opposite over adjacent, 3 over 4. Of course, it's going to be negative because we're in quadrant 2, and that's why I put that there earlier. And then last but not least, cotangent is going to be flip of that, so you're going to get 4 over 3. So just like that, we solved for all 6 trig functions based off of the given information, okay? If we recap, first step we did was identify what was positive. Based off the quadrant 3 and the fact that we started positive, we know what's positive. My second step was what? I needed to draw my triangle. These are all 4 possible triangles you would draw. Of course, they would have their right angles in there. But we only really needed 1. I showed you all 4, but in the future, you're just going to draw 1 that you need. Once you have the labels on it, you use the Pythagorean theorem to solve for the other side. And then after you solve for the other side and you have the completed triangle, you can go ahead real easy and find all the values of the original 3 and their reciprocals. All right, see you in the next problem.